Hi, my name is Stephanie, and today we're going to be speaking about amylopectin. So, providing a brief discussion of how we come about with amylopectin, large carbohydrates that consist of many monosaccharides linked by O-glycosidic bonds are called polysaccharides. Polysaccharides play two important roles: energy storage and structure and protection. Two polysaccharides in this discussion are glycogen and starch. Glycogen consists of glucose monomers linked via alpha 1 to 4 glycosidic bonds in a helical fashion. The helical chain is branched every 10 or so units via a E alpha 1 to 6 glycosidic bond. So starch, the most common polysaccharides in plants used for energy storage, comes in two forms: amylose and amylopectin. Amylose is an unbranched polysaccharide that consists of glucose monosaccharides connected via alpha 1 to 4 glycosidic bond. Amylopectin is composed of alpha D-glucose C1, C4, and C1 and C6 linkage. Amylopectin is a water-soluble polysaccharide and highly branched polymer of alpha glucose unit found in plants. It is one of the components of starch. Glucose units are linked in a linear way with alpha 1 to 4 glycosidic bonds, as well as a 1 to 6 bond occurring at intervals of 24 to 30 glucose. We will now look at the structure of amylopectin. So this is my diagram of how I am going to show the linkage, the alpha 1 to 4 linkage and 1 to 6 linkage. As you can see, I've already drawn the glucose monomers at the top and at the bottom, and I'm going to demonstrate the linkage and what is going to happen when we lose certain elements. So in this demonstration, we already see that we have the OH to the bottom and we have the element CH to OH at the top. So we already know that this is an alpha, right? I've already labeled all the carbons, and we have carbon 1, 2, 3, 4, 5, and 6. We have carbon 4 on this side. I've already lined them up in order for us to get our 1 to 4 linkage. So what is going to happen? We have to lose water. And we know water is H2O. So we're losing 2H and we're losing an O. That's easy. When we lose the H and the O, the 2H and the O, we remain with oxygen. And this is called a hydrolysis reaction. And here we get our alpha 1 to 4 glycosidic bond. We can do the same thing for the 1 to 6 linkage as well. Again, we are losing the OH and we are losing the other OH and the other element on the 6th carbon. So when that is lost, what is going to happen again? We get an oxygen, and it's a hydrolysis reaction. And we call this the alpha 1 to 6 bond. So I'm so happy that you guys are still with me after the discussion of our linkage, our 1 to 4 linkage and 1 to 6 linkage. What we're going to discuss now is the differences between the glycogen and the amylopectin, because we know that they kind of are very similar with the linkages. Um, they're kind of similar with linkage, whereas the glycosidic bond on the glycogen, it's a helical fashion, and they branch every 10 or so units, whereas the amylopectin, they would branch at intervals of every 24 to 30 glucose. So let's delve into that a little. About the differences about amylopectin and glycogen. Amylopectin and glycogen are both polysaccharides. These polysaccharides are a great source of energy for us as humans. However, amylopectin is a soluble form of starch, while glycogen is a soluble form of starch. The great source of amylopectin comes from plants, which includes rice, corn, potatoes, and starchy foods. On the other hand, glycogen found in the meats, intestines, and liver of animals. To be able to break down amylopectin, we need to heat or cook our food. Our saliva, which contains an enzyme called salivary amylase, also helps break down amylopectin. On the other hand, glycogen can easily be dissolved in water. When it's dissolved in water, it takes the form of glucose. In other words, consuming plants and animals as food is very vital for our body system to get the necessary nutrition they need. Plants can store approximately 80% amylopectin, while animals can store glycogen to approximately 2,000 calories. Both polysaccharides need to be stored in order to have a stable and steady supply of energy. And that would be the end of my presentation. Bye.